In this video, I'd like to show you a 3D viewer for Data Science Bowl 2017. The final result looks like this. Here is the nodule. Here is the page that you can download the data. All training datasets are inside this stage 1.7z zip file. After you download it and unzip it, you will see a lot of folders that look like this. Each folder is corresponding to a patient, and inside each folder there are a bunch of DCM files, which are the CT scans for this patient. We are going to use the software called Fiji to view these DCM files. Fiji is an abbreviation for Fiji is just image J. You can download Fiji at here. It's a cross-platform software. Fiji is originally written in Java, but you can integrate other languages like Python or MATLAB to it. It is widely used in image processing. After you launch Fiji, you will see a window looks like this. Here's the menu bar. Here's the toolbar. This is the status bar. You left single click it, you will see the version. Here's the versions I'm using right now. You can search online for Fiji status bar. You can read the documentation. This is the getting started documentation. What do you have in the menu bar? What do you have in the toolbar? And what's the function of status bar? You can just drag and drop the image folder to Fiji status bar to open it. It asks you whether to open all images as a stack. Click yes. This is a stack, means that all images are associated to each other. Oops. The first image, there are all 134 images. You can see when you navigate, it will show you the current image. The examples here are chosen from a video here. This video is recorded by Dr. Bram van Gineken. It's very useful that it shows you where the nodule is. According to that video, this one is a non-cancerous example. Let's see the other one. Oh, by the way, I want to mention that when you move around this image, the status bar will show you the XY position and the value. The value here, it shows as minus 1000. But when I opened this image in MATLAB with decom read function, the background value is minus 2000. So there are some differences between these tools. But it's fine if we just want to view the nodule, because you can see it here. According to the examples in Professor Gineken's video, here it's the nodule, and it's the malignant nodule that will cause cancer. I also want to mention that Fiji comes with an orthogonal viewer. You can shift and then scroll it to zoom in and zoom out. Image under image stacks. orthogonal views. You can switch to the orthogonal view. Here you can see in Z, this is the Z dimension. In Z dimension, you can see the slice. Here is a nodule. YZ, which is X dimension, you can see the nodule, this one XZ nodule here. But this is not our focus today. We want to view this image stack in 3D manner. Here you can switch to 3D view, plugins, 3D viewer. It asks you some parameters to build the 3D object. I only want to change the resampling factor to 1. It asks you whether to convert the image to 8-bit because it's originally 16-bit. This ImageJ 3D viewer only supports 8-bit or RGB images. So you click OK, wait for a while. Here is the 3D object. You can drag and move to rotate it. You have to click ImageJ 3D viewer to access its own manual bar. Under Edit, Display As, you can change it to Ortho Slice. But before that, I want to add another one. First, let's delete. Add from image 1. You can shift click it to move it. Add the other one. Scroll to zoom in or zoom out. Then you can change the view to display as ortho slice. Here we go. Let's find that nodule here. You can choose the object, right click, adjust slices to change the slices position. Z position should be 29 or around 30. Yeah, here. So the nodule is here. Then you zoom in, further zoom in. You can also use the other keyboard shortcut. 31. Click OK. You can press Z on your keyboard and scroll to change the Z slices position. Then Y, X. Okay. Let's see what you get. Here, here is the nodule, but it's we want to look at it in a volume manner. Since there is too much background here, and some other tissues and bones that blocks your vision, so you cannot see it very well. But here are some tools that in Fiji that you can use to you have to click on the object and then choose the adjust threshold. So now you can see the bone structure, but it's not so handy that you can keep only in this area. You can use other software to filter the other areas out, or some other tools in Fiji. But here I'm going to show you a very simple way to do that. To crop it. I want to keep some bone areas as a reference. Click Edit Clear Outside to clear outside the selection box. Yes to all. And then Image Corp. Then Plugins 3D Viewer again. One. Okay, here is the nodule. View start animation to see all to view it from all directions. The rendering sometimes is not so good. You can further zoom in and then scroll in the other direction to zoom out to view the whole structure. So I hope this 3D visualization can give you some insights when you designing the features for machine learning or other algorithms. Okay, let's look at the other example. According to Professor Ginnakin, in this example, the nodule is here. Use rectangle. Oops. Use rectangle tool to select it. And then add it, clear outside. Image Corp. Plugins 3D Viewer. Oops. Sometimes the zoom in, zoom out does not work very smoothly. Here is the nodule in this example. Okay. This one is smaller than the example we saw just now. And this one, the nodule is linked with 3 vessels. 1, 2, 3. Okay, that's it. After I made the video, I have an idea of using VR to help doctor to perform the diagnosis. People can construct 3D objects and load them to VR, and then allow the doctor to move around as he or she wants, to change the threshold to hide some background bone areas, and to view orthogonal slices at any position, and also perform measurements as he or she working inside the VR. And this can be also used for education purpose, for courses like biology, physics, and so on. The primary purpose of this video is to introduce 3D viewer and Fiji to Kagglers. I also hope it can serve as a connector to connect folks from different communities, like Fiji users who are doing image processing, Kagglers who are doing machine learning and artificial intelligence, as well as doctors. For example, Kagglers may want to ask questions on Fiji's forum about image processing, and Fiji users may also ask questions on Kaggle's forum about machine learning. Doctors may give comments to programmers. With that, I want to say thank you to Professor Bram van Ginnekim. The making of this video is inspired by his video. Also, Booth Allen Hamilton and Kaggle and its related foundations who present Data Science Bowl 2017. Also, Fiji and the 3D viewer developers. The licenses of all referenced works can be found at their websites. All other materials in this video is under the MIT license. Thank you for watching the video.